Okay, so this recording is for Unit 4, Test 1, Review Analytic Trigonometry, and we're going to be looking at problems 3. There happen to be two problem 3, so we'll do the first one first. Okay, so we're given cosine of alpha equals -4/5, and the sine of beta equals 12/13. So when you see a problem like this, what you want to do is you want to draw your triangles in the correct quadrants. So how do you know what quadrant? First off, let's look at our first one. Cosine alpha equals -4/5. I know that in quadrant 2 and 3, that's when cosine is negative. And I'm also told that sine of alpha is greater than 0. I mean, that have to be in quadrant 1 or 2. So the thing that those two conditions have in common is quadrant 2. So I'm going to draw a quadrant 2 angle, and I'm going to make it a triangle. And what I'm going to do is I'm going to label the sides that we're given. Remember, cosine is x over r. So I know that the x is a -4 and the r is 5. The reason I put the negative with the 4 is because r's are never negative. Okay. Now I can either use Pythagorean Theorem or my understanding of the special triple triangles, and I know that this is a 3, 4, 5 triangle. So my missing vertical side is 3. I'm going to do the same thing with my second trig, let me go ahead and label this triangle so I don't forget later. This is my alpha triangle. So I'm going to do the same thing with my beta triangle, but in this one, sine is positive, so I know I'm in quadrant 1 or 2, and I'm also told that tangent is greater than 0 or positive, and that happens in quadrant 1. So I'm going to draw a quadrant 1 angle. Let's draw the angle, or triangle, I mean. This is my beta triangle. And from the information again I'm given, remember sine is y over, whoops, sorry about that. Sine is y over r. So I'm told that y is 12 and the radius is 13. So it doesn't matter if your triangles are to scale or whatever, as long as they're in the right quadrant. So I can again either use Pythagorean Theorem, or I can recognize this is one of my triple triangles, so that means my x is 5. So whenever I do my problems, cosine is x over r for the specific triangle, alpha or beta. Sine is y over r for that specific triangle. So let's do the first problem that's listed here, the cosine of alpha plus beta. So the first thing I'm going to do is I'm going to rewrite my identity with just alpha and beta. I'm not changing the angles. The angles stay alpha and beta because I'm not told anything about the values of the angles themselves. So my identity that I'm going to use is cosine alpha, cosine beta, minus sine alpha, sine beta. And that's straight from your yellow foldable, okay, which you will be able to use on your test. Now, again, I'm not changing the alpha and the beta because I haven't been told what values those are, but I do know the values of the trig that goes with them. So cosine alpha, I was already given, is -4/5. Cosine beta is going to be 5/13. And my second term, sine alpha, is going to be 3/5. That's the y over the r. And the sine of beta is going to be 12/13. Now my last step in this problem is to simplify or multiply my fractions together and then combine them. So notice that both denominators have a 5 and a 13. So 5 times 13 is 65. And my first numerator is going to be -4 times 5, so that's a -20. And the second one is -3 times 12 is going to be a -36. So the last step I want to do is I want to combine together my two numerator values. So -20 minus 56 is going to be -56 over 65. Okay, so my final answer is going to be that. If that fraction at the end could be simplified, then you would want to make sure you simplify it. Okay, we're going to do something very similar for the second portion of the problem, the sine of 2 beta, but we're going to use our double angle identity, which we just learned. So the angle identity is 2 sine of beta cosine beta. So notice I did not change my angle because I don't know what beta is worth. So all I'm going to do now is I'm going to take my trig ratios from my triangle, just my beta triangle. So it's going to be 2 times the sine of beta, which was 12/13, times the cosine of beta, which is 5/13. Okay, so now this 2 is part of the numerator, so I'm going to say 2 times 12 times 5. And that's going to be over 13 times 13. So if I multiply those numbers, 2 times 12 is 24 times 5 is 120. Or you could say 2 times 5 is 10. 10 times 12 is 120. 13 times 13 is 169. So my final answer would be 120 over 169. Alright, so now let's look at the second problem 3. And on this one, we're given a cosine x equals a ratio, which seems very similar to what we just did, but let's pay attention to what the question is asking. We're told it's the first quadrant angle, and what is the value of sine of a different angle? Now pay special attention to what's in the parentheses. Pi over 2 minus x is the same as 90 minus x. So that means this is a cofunction. And remember, the sine of an angle is equal to the cosine of its cofunction, or of its a complementary angle. If the two angles add to 90 degrees, the sine of one is the cosine of the other. So if you go to your cofunction tab of your yellow foldable, you will find that the cosine of x is equal to the sine of pi over 2 minus x. So what that tells me is that my answer is simply going to be 5 over 13. And that's all you have to do for cofunctions. Just recognize that's what it is, and then write your value.